Section 2.1, inductive reasoning and conjecture. So our main ideas in vocab. Alright, so a conjecture is just an educated guess based on known information, and inductive reasoning is the process of using examples to arrive at a conjecture itself. So for example here, so you have the numbers 1, 3, 6, 10, and 15. They're called triangular numbers. Make a conjecture about the next one. They're called triangular numbers because you do them with dots: 1, 3, 6, 10, 15. You can make them dots of triangles. So if you notice here, you add 2, you add 3, you add 4, you add 5. So the next one is going to be whatever 15 plus 6 is, or 21 would be the next triangular number. Alright, so example 2, for points P, Q, and R, PQ is 9, QR is 15, and PR is 12. Make a conjecture and draw a figure. So if you notice, they can't all be on the same line because the sum of two of them don't add up to the third. 9 plus 15 isn't 12, 15 plus 12 isn't 9, and 9 plus 12 is 15. So that means they have to be in a triangular shape. Since QR is the longest, it would be here, which means P has to be here. So PQ is 9, PR is 12. Okay, conjecture, oops, that should be must. Must be true in most instances but false in the others. Actually it's not must, it's may. May be true. So if there's anything that proves your conjecture false, your conjecture is then false. It cannot be true. So that false example is called a counterexample. So our last example, find a counterexample for the following statement based on the graph. The population of these U.S. states increased by less than 1 million from 1990 to 2000. So you need to find some example of a state whose population increased by more than 1 million. So for example, this guy right here, who I believe it's kind of hard to read, but that's Arizona. So Arizona population increases by more than 1 million. So that is the counterexample to that statement. That's the end of the section.